Good morning, dear students. I am Dr. Srinivas Patine, Professor of Chemistry in Sri Academy, Hyderabad. Today, the last topic of reaction intermediates, they are the Carbenes as well as Nitreens. We have to discuss clearly. Okay. So, what are the topics? Today's topics are Carbenes and Nitreens. Carbenes as well as Nitreens. So before that we have discussed the free radicals, carbocation, Carbenes. All these are reaction intermediates. We know that the importance of that intermediates. So what about the Carbenes? Carbenes are highly reactive species. Practically all having a lifetime considerable under 1 second. The lifetime is only 1 second. You know that the parent species, that is CH2, this is the parent species, is usually called methylene group. What is that? Methylene group. Methylene group. Methylene group. This methylene group, the derivatives are more often named by the carbon nomenclature. Methylene derivatives. The nomenclature it is usually. That is the the CCl2 is generally known as Dichloro Carbene. CCl2. You know that though it can be called as dichloromethylene, CCl2 is a dichlorocarbene or dichloromethylene. You know that CCl2 in place of H2, just this is called the dichloromethylene. Methylene, dichloromethylene. 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 Or dichlorocarbene. You can say dichlorocarbene. Dichlorocarbene. So methylene group 1. Dichlorocarbene or dichloromethylene. So generally it is a neutral divalent carbon intermediate. We can say neutral divalent carbon intermediates, on which carbon is a covalent bond. Two atoms are there. Covalent bond with the 2 atoms, that is CH2. 2 atoms are there. And has 2 non-bonding orbitals containing 2 electrons between them. Because the 2 are covalent bond and non-bonding are also there. They are containing 2 electrons in between them. Generally, in the classification, we have to know that 2 possible carbenes are there. 2 types of possible carbenes. Types of carbenes. Or we can say they are single carbene and triplet carbene. Singlet carbine and triplet carbene. So there are the 2 possible carbenes are formed. 2 carbenes. The number 1 is the singlet carbene. Singlet carbenes. There are the 2 possible carbenes. The number 1 is the singlet carbene and the number 2 is the triplet carbene. Triplet carbenes. There are the 2 possibles. 2 possible things are there. So one is singlet carbene, another one is the triplet carbene. Triplet carbene. So first of all, we have to see the singlet carbene. This is the singlet carbene. How? In this, if that p orbital, we can see the unhybridized p orbital remains vacant. It is look like a carbocations. It's look like a carbocations. If you see the diagram, we can understand. This is the diagram. This is the two hydrogens. That is the two hydrogens or two something. R group. We can write in place of R. The carbene, you know, the carbene. Here, this is containing the two electrons, and p orbital is there. P orbital is there. So, mean in this is the what? Singlet carbine. Singlet carbine. One unhybridized. This is unhybridized p orbital. It's a vacant. Okay. So just like in the carbocation we have seen, it's look like a carbocations. Okay. Next, in the case of triplet carbene, what is that structure? Triplet carbene. Triplet. So triplet carbenes, it is sp hybridized. sp hybridized, and it is linear or near linear species. Linear or near linear spaces. These two hybrid orbitals are involved in this. Two hybrid orbitals are involved with two groups, and the two electrons are placed each. I mean, one electron is one lobe, another one is another lobe. I mean, these electrons have parallel spins, not opposite spins. Not like this. These are the opposite spin. So, if you can see the diagram, we can understand the structure of this triplet carbon. Here, same thing. So, see, this is the. So, this one, but here that. This is the one R. We can see another R. Then two covalent carbons. Here, two parallel spins in this one electron and another one electron. Here. So here also this one. Okay. So this is the structure of triplet. Here mean that it is in like sp hybridized and linear in structure. And each lobe is having parallel spins of electrons. The electrons look like a parallel spins, not opposite spins. So it is therefore responsible to believe that the triplet state of the carbene mean it is more stable than the singlet one. Once in IIT they asked which carbene are more stable, either triplet or singlet. Triplet is more stable than the singlet state and should be accepted, mean expected to the ground state. Should be expected to be ground state. So these are the two structure, two possible triplets and singlet. Okay. So now how it is formed? What is generation? Generation of the carbocations. Generation. Let's see the carbenes, how they are generated. How they are generated. The generation is important. So generally, thermal and photochemical cyclopropanes and oxiranes is a common method of generation of carbenes. Oxiranes as well as cyclopropanes. Cyclopropanes, we can cyclopropanes. Cyclopropane. This is the cyclo. Oxirane means oxygen. That is cyclopropane and oxiranes. So mean that type of compounds generate the mean carbocations. In where? In thermal condition or photochemical condition. For example, you will see this carbon like if this is the compound, you see this is the compound R C double bond C, you can say C double bond O. So this compound is there. So here in the case of thermal condition, thermal meaning you have to eat, or H nu or photochemical, or H nu. So either photochemical or thermal condition, what happened? It is formed like a singlet generation of the singlet generation. This is the singlet. So mean two electrons are there. Just before we have seen that. So these two electrons are opposite, and two mean that one is the p anhybrid is p orbitals. These two are the covalent compounds. Okay, and carbon monoxide is released. This is called the singlet generation. Singlet generation of carbene. Singlet generation. In the case of one more example, if you take the RCHX2, X mean iodine or bromine or one. In the presence of base, any type of base, so what type of compound is formed? So the compound is RCX2 formation takes place. Base means sodium chloride or sodium bromide. RCHX2, this is called the RCX2. Mean here, so two electrons are there. If you can aid or thermal condition or any condition, so here then I can form the carbonides can formation takes place. Mean the X is removed. RCX mean in the presence of base mean any base like lithium compounds or sodium compounds or any type of base we can use. Now the carbinoid formation takes place. This is the carbinoid formation. Carbinoid formation takes place. Carbinoid. So this means X is released, and this is called the carbinoid. Carbinoid formation takes place. Carbinoid in the presence of lithium hydroxide, or lithium, or we can say any type of base. If we can say directly or lithium, how it is possible? So here so directly see that if RCHX2 lithium mean lithium we can say this is the lithium, okay, or gas lithium. This is the base compound. So what happened here? So removal of minus Rx. This R is removed and replaced by the R here. So what type of compound is formed here? RCX, H, and R formation takes place. Sorry, lithium formation takes place. Lithium first of all. This lithium will come here. So lithium. Okay. And then again the X is removed and carbonide formation. And removal of X and carbonide formation. This is the carbonide. Okay? So this is about the carbonide. Carbonide formation takes place. And what about the stability of this reaction? The stability due to the resonance. The stability of carbenes increases. Okay? If resonance is increased, that stability also increased. Okay? And now, nitreens. We have seen the nitreens. Only two reactions are there in the nitreens. Nitreens. Here also, nitreens are the analog of carbenes. we can say analogs. Analogs means similarly. Analogs of carbenes and nitrenes are too reactive. It's very reactive compounds for isolation under ordinary conditions. They are the singlet and triplet. The singular structure of nitrenes is like this. This is the singlet. Singlet nitrenes and triplet nitrenes. Triplet nitrenes are like this. This is called the triplet. Triplet and singlet. This is the singlet nitrenes and this is the triplet nitrenes. So both are in carbenes also singlet is there and triplet is there, and now the last two reactions generation we have to see. One is the elimination, another one is the breakdown of double bond compound. So this is the last topic. Within 2-3 minutes we will finish that one. So how to generate the compound, this compound. So just one example I will give you. The nitrene formation is a very easy. That nitrogen compound, any nitrogen, or say here that what compound so we can OSHO, we can say OSHO2, and really it is attached with the organic compound. This type of compound we have to take it. This compound when react with the base, so what happens? This group will removed outside. The base react with the hydrogen. This base react with the hydrogen, and this will be breakdown. And the simple formation is the RN formation takes place, and plus OSH, OR2, SHAR, and base mean BH, mean base hydrogen, BH. You can say BH plus BH. RN, BH, and ASO2. So, for example, here, this is about the elimination. Elimination means we have to eliminate. If we can write this one minus. Okay. So remove this one. This is the structure of eliminate this compound. Elimination of compounds. So the formation of nitrenes by elimination of some organic compounds. Okay, and breakdown of certain double bond compounds. Breakdown. So breakdown mean double bond mean C double bond N double bond N. For example, this is the what compound? R2 this is the compound, for example. So if you can take either nitrogen or oxygen, nitrogen we have to take, because the nitrogen compound means you have to take the nitrogen. One is the plus, another one is the minus. Okay, so this compound when we have to eat in the presence of H nu or H nu in the presence of heat or thermal condition. So what happened? So it will break down the double bond. The double bond will break down here. Mean these double bonds. So what compound is? Singlet Carbenes formation takes place. The singlet carbine is this one. The singlet nitrogen. We can say nitrenes. So nitrogen is nitrogen. So this is the generation of nitrenes, either elimination or breakdown of certain double bond compounds. Okay, so this is the topic. Today we have discussed the carbenes and nitrenes. Okay, thank you very much, and please don't forget the subscription. And in the next class, we will see some named reactions. Okay, so these are we have discussed a lot reaction intermediate and displacement reactions and nomenclatures are the basic compounds we have discussed. And in the next class onwards, we will discuss the preparation and properties of some of the compounds. Preparation and properties. Okay, thank you very much.